Physics, gravitational field, force and energy. Gravitational force. Gravitational force is proportional to mass and inversely proportional to the square of distance between two bodies. The equation relating the force F between two masses, big M and little m, a distance r apart, is shown here. Big G is the gravitational constant. The minus sign is because gravity is an attractive force, and so acts in the reverse direction to the outward measurement of distance from the body of mass big M. Gravitational field strength, little g. By Newton's second law, force equals mass multiplied by acceleration. It follows that gravitational force is mass multiplied by the gravitational field strength. Rearranged, this becomes little g equals F divided by little m. Substituting this into the equation for gravitational force, we get little g equals minus big G multiplied by big M and divided by the square of the distance of big M from a test mass of 1 kilogram. Gravitational potential and confusing graphics. Here is the equation for the gravitational potential V due to a body of mass big M at a distance r. Note the minus sign. Essentially, the little m is replaced by 1 for a 1 kilogram test mass. Graphs can be misleading. Here, the gravitational force is shown as negative, as we would expect from the equation. But here it is shown as positive. This graph actually shows the modulus of the force. The graphs for the modulus of gravitational force and gravitational field strength are sometimes confusingly shown together like this. A similar looking graph is that for kinetic energy and gravitational potential energy against distance shown together. Finally, do not confuse the little g mentioned above for gravitational potential, which decreases with distance, with the little g used for problems near the Earth's surface. That is a constant and causes gravitational potential energy to increase linearly at small heights above the Earth's surface. Circular motion of one body around another. Centripetal force F is given by the equation. F equals minus the mass, little m, multiplied by the square of the tangential velocity, v, divided by the radius of orbit r. The minus sign is because centripetal force is directed towards the body of mass m. From this, we get an equation for the tangential velocity in terms of big G, big M, and r, which is very useful in respect of satellites and planets. Gravitational potential energy. Gravitational potential energy U is given by the equation shown, where big G is again the gravitational constant. Big M and little m are two masses a distance r apart. Notice the minus sign. It is true that total energy cannot be negative, but gravitational potential energy can. The graphs for U against R can vary. In this graph, it is shown as negative as the equation says. But in this graph, it is shown as positive. This graph is really showing the modulus of U against distance.